Okay, we're standing here next to the Rescue League, and here's Floridor from the Belgian Army.
Yes.
And what is your exact function?
So I'm EOD, that means demining, explosive ordnance disposal. And we are here with our robots because we use them quite a lot, actually.
And it's a robot designed to defuse bombs?
It is designed to defuse bombs and to observe the environment.
Yeah. So what are the capabilities of this robot?
The capabilities are primarily to reach places we want him to go. Like now it's climbing stairs because it's rarely that we go to a place that is perfectly made for robots. When it's on situation, on site, he will observe. So it has quite a lot of cameras with good capabilities to see what we need to see, because probably it's a place we've never been before. That's the job. And then it can place and shoot disarming weapons, so that are not conventional weapons, not with bullets or ammunition, but it shoots a water weapon, and that water will do a disruption in the bomb.
So it's armed as well, but not lethal.
It's per definition armed, yet I think it's not really intuitive correctly to say it's armed. It's armed with water.
Okay. And is it an autonomous robot, or do you have to control it?
It's not autonomous at all. It does some movement on command on its own, but always on input from an operator. And the most important movements we do ourselves, because it is a robot of 6 years old. AI wasn't a thing back then.
Okay, and what are you doing here at the RoboCup? Are you looking for new input IDs, or what are your exact things you're doing here?
We are here for two reasons actually. One, to see what's in the market. No, not really in the market yet, but what will be in the market in the future, so we know what to look out for. And secondly, to show the teams why they are doing it. So we have our bomb suit with us to show them how cumbersome it is, how heavy it is, and the goal is that their robots make that bomb suit not necessary anymore. So we show them why they do it, and we try to give them some insights in what it is in real life, because now they have well-defined training lanes. In reality, everything is a variable. So we give them a little bit feet on the ground perspective.
And have you seen some cool robots you like to have in your army?
I have seen a lot of cool. All the robots here are cool, and I want to have them all, but not on duty yet, because they are prototypes. They do their job well, but every time you speak with someone, they say, it did that, did really well, and then the motor burned out. Mm-hmm. Reliability is very important to us, obviously, and it's impossible to have a prototype that's reliable. Okay. So if I can take one for myself, I will, but not for the service.
Perhaps in a few years they're reliable and their prototypes are...
We hope so.
Okay, thank you.
You're welcome.
I'm standing here with Tom. Tom is one of the judges and the referees for the competition, for the rescue robot competition. But there's so much more about him, because he also helped design and build all these obstacle courses, or how do you call it?
Yeah, so typically we call each one kind of an apparatus for a lane for running the obstacle courses.
Yeah. And you have quite some experience, because what's your background?
So I was with the City of Los Angeles Fire Department for 32 and a half years. I worked heavily with our urban search and rescue program. I worked with our Swiftwater program. I worked with our dive rescue program. Worked in our wildland fire unit, supervising heavy equipment for big wildland fires across the state of California. So I have a pretty wide, broad background in disaster work. And I've been able to bring that experience into helping us develop these test methods, so we have a fairly realistic disaster type environment for the robots to be challenged in.
And you also worked with robots, or did you do it all manually?
We were pretty much all manually until the later end of my career, when we started to get some drones for doing some aerial reconnaissance work. City of Los Angeles did get a firefighting robot that is kind of like the robot that was used at Notre Dame when they had the fire there.
Okay, not to
And so they could remotely control the hose lines and drive them into put out fires. And we use that for large warehouse fires where their buildings are hazardous and possibly ready to collapse. And in conjunction with our heavy equipment unit, help put out the fire and then remove some of the debris so that we can make sure the fire is completely out.
Yeah, so you got quite a lot of experience in disaster areas. And what is so the most dangerous or most hazardous environment you've met in your career?
Well, probably running into structure fires is the most hazardous, but I've been at wildland fires where we've had the fire burning on us and we've had to go to our safety zone, push out a safety zone area and wait for the fire to burn over and then get back out and go again. When, it's that Northridge earthquake and I was on the first level of the Northridge Meadows apartment. We were searching and then we would get aftershocks.
Okay.
And you got to wait around for that. When we went to the World Trade Center, we had an explosion in the pile as we were trying to do some searches in the rubble. And so it shook the whole rubble. One of the other search and rescue teams next to us from Indiana was involved in that. A couple of their
so you had to rescue a rescue team.
Yeah, so they were pretty much, and we just went over and made sure that they had everything handled. A couple of the searchers got burned a little bit on that, not too bad, fortunately, but so helping each other out in that fashion.
And all this experience, how do you simulate fire here also in these?
No, this is mostly for disaster from the standpoint of explosions, natural disasters, hurricanes, earthquakes. And so those kind of environments is what we're really trying to simulate. The fire department in New York, they have a very robust robotics program. And several months ago, they had a parking structure collapse. And it was still actively collapsing when the first firefighters got on scene. And so they called the robotics unit in so that they could send their drones and their Boston Dynamics spot dog to go in and inspect the structure, find where the victims were, determine which ones were the viable victims, and then the firefighters had limited their risk by going directly to where the victims were, extricating them and bringing them back out. So it really provides that extra ability to limit risk for your fire. You can't get rid of all the risk, but now that we can go in and make assessments without exposing the firefighters, now we know where we need to focus our attention.
So the robots are merely the first responders, reconnaissance, mapping the area, and then giving this intel back to the real firefighters and the real rescuers.
And then they, like for a spot, if there's unlocked doors going through, they can open those up and help expand the search area for drones. And drones are very quick at going in and doing it.
But they can't open doors.
But they can't open the doors yet. They're not quite there. So a spot can come in where they weren't able to access if the doors are not blocked or not locked. Now they can expand that without really exposing the public safety. And the same thing goes in a standoff with SWAT team, right? And so you can get spot or drone to go in, and so you're not risking one of the police officers to go in and do some of those searches or open up some doors if they're not locked. And then they can really focus their attention on what they need to focus on.
And then some of these first responder tasks, you have managed to mimic them in these contraptions.
So we simulate that. So you see here, like we have our door obstacle. The robots are opening the doors. You can see that we've got sand and gravel. So it's just like they're having to go through a dirty part of an area or collapse. You can see that we've got these obstacles where they're having to navigate through an area where they can't step off. So we're simulating
with rough terrain and equal. Yeah.
And so we have these different styles of rough terrains.
So what are, for example, a task a robot has to do within this obstacle course?
So like we were talking about with the visual acuity, they do that portion. And also we do what we call some dexterity tasks. So here you can see we've got some holes and some metals in these pieces, and they'll take a tool that's in there, grab it, they'll pull it out, and they'll go to a different hole and insert. So they're basically demonstrating the dexterity to do fine motor control for placing.
Yes, it's really a nice small. Yeah, it's like fingering, like using your fingers to open and.
So you're working on that where you really have to have good fine motor control, right? And I'm putting those in there, and then just how much quicker when they start adding some software autonomy to these platforms, they really start doing some good learning, and then you can see that they start improving.
So how difficult is it for a robot? Because on the one hand, he has to maneuver through this terrain, and then he has to do this fine control with this.
At different elevations also, right? You can see here, this is going to be a little different than this task over on this side, right? Where we're running on there as opposed to coming up there. So we change it up a little bit so that we're getting a wide breadth of the capability of the robot and their ability to do fine motor control, have good visual acuity, and it really runs that whole spectrum so that you're getting a well-balanced platform when they're successful at all those things.
And have you seen robots succeeding in all the tasks?
So we have, they have been succeeding in all the tasks, and so the next thing has been autonomous behaviors, right? So that's the next step for us, and so as part of that, we grant more points for robots that are doing it autonomously, right? Without any human interaction, they're doing all the insert tasks, right? So the university students that are developing these are developing the software to machine learn the robot to go perform those tasks. So.
And what's the use in a real life situation to have an autonomous robot do that?
The more autonomy that the platform has, the more the operators can focus on the situation, and the less they're doing like, what do I have to do to maneuver this part, right? And so you get so focused on maneuvering that now you're not getting the full spectrum of the situation. Where the more autonomy that the robot's performing, the more you can focus on the things that need to get accomplished within the mission set. And so you're going to be much more efficient in going through those.
You can watch the surroundings and help victims and coordinate your team and so, yeah.
Yes.
So now they're getting 2 minutes to set up before they start.
4 minutes to set up. There's 2 minutes left in their setup procedure. And so it's time for them to set their platform up, get their robot in position, get ready to start. Once the gong goes off, then they can start their mobility mission. So this is for them to just go back and forth as many laps as they can get, up to 10 within 10 minutes.
Just moving around through the obstacle course.
Driving through. After that 10 minutes is up, now they do the dexterity task. They'll, wherever they end up, they can go to the closest dexterity task and they can start on that. And they have 4 dexterity tasks to finish within 10 minutes.
Okay.
Then once they complete that, they do a victim box, which basically is one of these.
Okay, 1 minute to go.
So now, once they're complete with their mission, we want to make sure that all their sensors are still working. So we have an autonomous recognition of labeling. So they're actually, a robot looks in there and it'll pop up and say, this is a flammable solid. And then you see that. This is a thermal imaging one. So in here you can see the gaps, and now we see how good their thermal imager is. They got to see at least the second gap, first gap and that second gap. And they get all the points for that. And then we have a motion detector in here. So again, this is autonomous behaviors. And so you'll see that this spins, and autonomously, as you're looking on their interface, it'll say, oh, I see motion, and it shows it on the screen, pops up. So autonomously, it's detecting motion. Autonomously, it's detecting the flammable liquid. You're looking at the thermal camera. The operator tells you which C is and the direction it's pointing. Here we have a magnet that's underneath here, so they have a proximity detector. It's a magnetometer that, as they get close to it, you can see it change from the magnetic field, right? And then we have a speaker under here. It's a victim, so that's making noise, and then you listen to see if you can hear the mic on the platform coming back to the operator station. And then visual acuity again, and then the operator again is just looking to tell you what the third C is.
The smallest one.
Smallest one, or just the third one in on this one. So that, for what we can see, is the smallest one, but there's actually 2 more past that.
Oh yeah, it's quite small.